Hey, this is Russ Miller. We're at the Gloral Lab with Hayden Henderson. We've got this new gloss glider. We're going to open it up and see what's inside today. So here we go. Socially distanced, of course. This thing's about 400 pounds in the case. The glider itself weighs about 150 pounds. Well, displaces about 56 liters of water. So whatever kind of water you're going into, salt water is a little heavier. So we got to lift it 2 feet to clear the fin. And there we go. Look at that. Brand new buoyancy glider. This is a Slocum G3. And sitting on a cart in this shipping case. These get shipped all over the world. As air freight, so they can go on oceanographic ships and be launched into the oceans of the world or the Great Lakes of the world. As we start at the back, let's start at the front. Up in the front, there's a buoyancy pump that changes the mass or the volume of the glider. The mass stays the same, so as the volume gets smaller, the glider gets less buoyant and sinks down. What's not on this glider, I'm going to borrow one from another glider, is a wing. There's a pair of wings on it so that as it goes down, as it pitches down just like a bathtub toy, pool toy, and it flies forward. And what's different about this is that when it gets close to the bottom, depending on how it's programmed, the pump pushes water out and makes the glider buoyant so that the nose pitches up and it flies up and flies forward due to that buoyancy change. So the wings go on it. In this forward section, there's the pump. There's an altimeter, so it knows how high it is off the bottom. There's a big battery in here. So with these, this has rechargeable batteries, and we think this glider can go out for about 60 days maximum. There is another extended bay. Why don't you grab that one there? This extended bay goes in between the forward, goes in between the science bay and that forward section. It makes the glider longer, but it carries another battery that will extend the amount of time it can run for about another, it should be close to 20 days. And Hayden's grabbing a battery. This is the battery that goes in that extended bay or the pitch bay, the forward bay. And this is 100 amp hours, 14.4 volts. So this is about like 15 big laptop batteries. It's about 20 iPads worth of power. So it's a lot of juice. And that's rechargeable now. Those used to be throwaway, so very excited. This is the science or payload bay. This has a PAR sensor that measures photosynthetically active radiation. PAR, we normally call it PAR. And this is the range, 400 to 700 nanometers of solar radiation that most affects things with chlorophyll, the growth on Earth of plants and algae. So that feeds that powers the phytoplankton that live in the lakes. There's a phycocyanin sensor down here which measures the blue-green algae in the water. There's a dissolved oxygen sensor right here on top. I think this is the first glider like this that has one of these installed. You can also measure chlorophyll A, which is the green algae that grows in the lakes and in green plants on Earth. And there's down here, there's a little red thing. We'll get these boxes out later. So this red unit here is a CTD. It's a conductivity, temperature, and depth sensor. So the CTD measures temperature, conductivity, and pressure.
Elementary physical parameters for oceanographic and in our case, freshwater study. Right.
So you should be on the other side, Hayden, because you're actually a limnology student of limnology. I'm an environmental engineer. I'm a mechanical engineer with robotics background. So this is a robot, but it's a science robot. So this is really, the CTD measures some parameters that go along with those other measurements. We want to know how deep it is. when we're measuring all those other things. And the conductivity tells us in an ocean situation tells us salinity. In the lakes, it tells us a lot about where the water came from.
Conductivity is a conservative substance, right? So it's non-reactionary in most cases. It's not chemically or biologically impacted, and it can carry a signature right from a riverine, terrestrial source through the lake, or again, just identify where and what the water's doing. Yeah.
Right. And we see differences in that in different lakes. And on the bottom, you can't see the chlorophyll and CDOM, which is the colored dissolved organic material, and which is another good indicator of tannins and other mostly biological substances in the water, biological origin. Where Hayden's kind of, sort of. Okay, CDOM anyway. And backscatter, which tells you how much light is being scattered back, which is usually related to how much sediment is in the water. The control section and another battery is in this aft section, and in the tail, there's a lot going on. There's a fin that can steer the glider. There's an antenna up here for GPS and Iridium satellite communications, so we can talk to it while it's in the water. Inside of here, there's an airbag that inflates when the glider comes to the surface, and it helps lift the tail up so the antennas come out of the water. There's a very important item right here. It's a little weight that can be ejected. It weighs 1 kilogram, so it'll make the glider more buoyant if it gets stuck underwater for 12 or 16 hours. There's what's called a burn wire in here. It's a little wire that gets current on it. It's a very simple backup system, and that starts to corrode that wire, and when it corrodes enough, that pops out and makes the glider lighter, so it should float to the surface. And then this is it's not brand new, but new to these gliders, in our experience, is it's got a little propeller on the back. It doesn't need the propeller to move. The buoyancy engine is plenty, and the old gliders, that's all they had. This new one has a propeller on it, and it folds for streamlined low drag configuration when it's not running, but as it spins, it'll fly itself out and propel the glider forward, and that lets it deal with stronger currents. If it needs to go more quickly for a little while, it can do that. Both systems take energy, so they're about the same in terms of energy. The thruster also lets it stay at the same depth for a long extended period of time. Normally we want to go up and down through the water anyway. It's very exciting. We'll get it out and run it through its paces a little bit and hopefully get it in the water this season.